National Electrical Code, or NEC, defines the service as the conductors and equipment that deliver energy from the utility company to the wiring system of a building. This includes everything from the point where the utility connects to the building up to the service disconnect, which is usually a main breaker or a set of fuses. The service conductors must be bonded to the grounding electrode system at the service entrance. This means that all metallic enclosures for the service equipment, such as the disconnect and any associated enclosures, must be connected to the grounding electrode system. The grounding electrode system typically consists of things like a ground rod, a water pipe, or a concrete encased electrode. The purpose of this bonding is to provide a low impedance path for fault current to return to the source, which helps to ensure that overcurrent protective devices, like circuit breakers or fuses, will operate properly to clear faults. After the service disconnect, the wiring is considered a feeder. Feeders are the conductors that extend from the service disconnect to subpanels or other distribution points within the building. Unlike service conductors, feeders generally do not require bonding back to the grounding electrode system unless they are installed in a non-metallic raceway or flexible metal conduit. The reason for this difference is that the service equipment is already bonded to the grounding electrode system, providing a grounding path for the entire electrical system. In the specific situation, the service boundary appears to be located at the disconnect. Therefore, the piping from the metering equipment to the panels is considered a feeder and does not require bonding lock nuts. However, there are several reasons why an electrical inspector might require bonding lock nuts in this situation. Firstly, the inspector may have a different interpretation of the service boundary. They may believe that the service extends beyond the disconnect to include the metering equipment. Secondly, there may be local amendments to the NEC that require bonding lock nuts on all feeders regardless of the type of raceway. Thirdly, the inspector may be concerned about potential harmonics or other electrical disturbances that could travel through the piping system. Harmonics are distortions of the electrical waveform that can cause problems with electrical equipment. Bonding the piping system can help to mitigate these problems. To address the inspector's concerns, firstly, consult with a local electrical inspector to discuss their interpretation of the applicable codes. It is important to understand their reasoning for requiring bonding lock nuts. Secondly, review local amendments to the NEC to verify the bonding requirements in the specific jurisdiction. Local amendments can vary from the national code and may include additional requirements. Thirdly, consider installing bonding lock nuts on the piping as a precautionary measure to address any potential concerns. While they may not be strictly required by the NEC, installing bonding lock nuts can demonstrate a commitment to safety and help to resolve any disagreements with the inspector. When dealing with electrical installations, it is always best to err on the side of caution and follow the inspector's guidance. In general, bonding lock nuts are used to ensure electrical continuity between metal enclosures, such as electrical boxes, conduits, and cabinets. They provide a secure and reliable connection that helps to maintain a low impedance ground fault current path. Here's a more detailed look at bonding and grounding concepts. Grounding electrode system. This system is crucial for safety. It connects the electrical system to the earth, providing a path for fault currents. Common grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes. Bonding jumpers. These are used to connect different metallic parts of the electrical system together, ensuring that they are all at the same electrical potential. This reduces the risk of electric shock. Main bonding damper. This connects the grounded conductor to the equipment grounding conductor at the service entrance. It is a critical component for establishing a low impedance ground fault current path. Equipment grounding conductor. This conductor provides a path for fault currents to return to the source, allowing overcurrent protective devices to trip and clear the fault. Ground fault circuit interrupters, or GFCIs. These devices are designed to protect people from electric shock by detecting ground faults and quickly interrupting the circuit. They are commonly used in areas where there is a risk of water exposure, such as bathrooms and kitchens. Arc fault circuit interrupters, or SIs. These devices are designed to protect against fires caused by arcing faults. They are required in many circuits throughout the home, such as bedroom circuits. Overcurrent protection devices. These devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. They interrupt the circuit when the current exceeds a safe level. Conduit types. Rigid metal conduit, or RMC. This is a heavy-duty conduit that provides excellent protection for conductors. It is often used in harsh environments. Intermediate metal conduit, or IMC. This is a lighter weight conduit than RMC, but still provides good protection for conductors. Electrical metallic tubing, or EMT. This is a thin-walled conduit that is easy to bend and install. It is commonly used in residential and commercial buildings. Flexible metal conduit. This is a flexible conduit that is used to connect equipment that may vibrate or move. Liquid-type flexible metal conduit. This is a flexible conduit that is designed to be watertight. Non-metallic conduit. This is a conduit made of plastic that is lightweight and easy to install. Understanding the National Electrical Code and local amendments is essential for ensuring safe and compliant electrical installations. It is always recommended to consult with a qualified electrician or electrical inspector if you have any questions or concerns. To further clarify the difference between service and feeder conductors and their bonding requirements, consider the following points. Service conductors. Service conductors are the main conductors that bring power from the utility company to the building's electrical system. They typically originate at the utility transformer and terminate at the service disconnect. The service disconnect is the main switch or breaker that allows you to disconnect all power to the building. Service conductors are required to be bonded to the grounding electrode system at the service entrance. This bonding ensures that any fault current will have a low impedance path back to the source, allowing the overcurrent protective devices to trip and clear the fault. Feeder conductors. Feeder conductors are the conductors that extend from the service disconnect to subpanels or other distribution points within the building. They carry power from the service entrance to various parts of the building. Feeder conductors are generally not required to be bonded to the grounding electrode system, as the service entrance is already bonded. However, there are some exceptions to this rule. For example, if the feeder conductors are installed in a non-metallic raceway, such as PVC conduit, they must be bonded to grounding electrode of the subpanel. This bonding is required to provide a ground fault current path in case of a fault. In this specific case, the piping from the metering equipment to the panels is considered a feeder because it is located after the service disconnect. Therefore, it is generally not required to be bonded to the grounding electrode system. However, the inspector may have required bonding lock nuts because of local amendments to the NEC or because of concerns about harmonics or other electrical disturbances. Here is some additional information about bonding lock nuts. Bonding lock nuts are special types of lock nuts that are designed to provide a secure electrical connection between metal enclosures. They have teeth or serrations on the surface that bite into the metal enclosure, creating a low impedance connection. Bonding lock nuts are typically used on service equipment to ensure that all metal enclosures are properly bonded to the grounding electrode system. They can also be used on feeder equipment in certain situations, such as when the feeder conductors are installed in a non-metallic raceway. When installing bonding lock nuts, it is important to make sure that they are properly tightened to ensure a good electrical connection. Over-tightening can damage the enclosure, while under-tightening can result in a poor connection. It is also important to use the correct size bonding lock nut for the conduit or fitting. In summary, the service entrance is where the electrical service enters the building and is bonded to ground. Feeders distribute power from the service entrance to subpanels and other locations and typically do not require additional bonding unless specific conditions apply, such as non-metallic conduit. The local inspector's interpretation and local codes are key to ensuring compliance. Always consult with the local electrical inspector and review local amendments to the NEC to ensure compliance with all applicable codes and regulations. Consider installing bonding lock nuts as a precautionary measure, even if they are not strictly required, to address any potential concerns. Remember to always prioritize safety when working with electricity.